Let K be a real number such that the system of these equations has exactly one complex solution Z. The sum of all possible values of K can be written as M over N, where M and N are relatively prime positive integers. Find M plus N. Okay, if you look at these equations closely, we see that the first equation says the distance between Z and this complex number is 5. So that's a circle with radius 5. And if you look at the second equation, we can write this as Z minus this thing, and Z minus this other number. So that tells us that the distance Z is equidistance away from these 2 points. And that is the perpendicular bisector line. So there's a lot of geometry going on here. So what we have is we want to intersect a circle and a perpendicular bisector line. And apparently the intersection has only one point. And the perpendicular bisector line is going to come from, so 2 points, let's say these are B and C. So we know 2 points in terms of K, and we are going to take the midpoint, draw a line perpendicular to BC, and intersect that. Let's say this is the point, let's say A. And we want the line to be 5 away from the point A, so that there's a unique solution for the intersection of that circle and line. Okay, so this is our game plan here. We are given everything in terms of K, and we are gonna find this line equation and then write the distance formula from a point to a line. So let's remember that distance formula first. So the distance from a point A, say with coordinate x, y, and a line with equation as ax plus by plus c equals 0 is given by this. You plug in these values, the coordinates of A, into this expression of the line, take absolute value, and divide by square root of sum of squares of x, y coefficients. Okay, so we know the point A. We need to find the equation of the line L. So BC, let's start with the line BC. Segment M is the midpoint. So let's say B has coordinates 4 plus k, so 4 plus k and 0, no imaginary part. And C has coordinates k and 3. So M is the midpoint of these, so it will have coordinates average of x and y coordinates, 2 plus k, comma 1.5. And if you look at the direction of BC, this has slope x decreased by 4, y increased by 3, so it's negative 3/4. So the line L, since it's perpendicular to this, it will have slope 4/3. So the equation of the line L will look like something like this. 3y minus 4x minus a constant is 0. And we can find that constant in terms of k by plugging in this point, because we know that point M is on this line. So 3 times 1.5 minus 4 times 2 plus k is this constant C, and that we get negative 3.5 minus 4k is our constant in terms of k. Right. So we are pretty much done with the line. Now we can use the distance formula. And I want to keep things in terms of C here for simplicity. And if we use the distance formula, the distance from A to line L, and we know this distance should be 5, is given by, so the line equation is 3y minus 4x minus c, and And we are dividing this by square root of 3 squared plus 4 squared, which is just 5. And I need to plug in x equals the coordinates of A, and they are 25 and 20. So x is 25 here, y is 20 here. Okay, so let's try it again. We get 5 equals 3 times 20 minus 4 times 25 minus a constant c, absolute value divided by 5. So this gives us 60 minus 100, negative 40. So c plus 40 is plus minus 25. So c is negative 40 plus minus 25. So we have two c solutions, and they will lead to two k solutions. And the relation is this. So k is negative 3.5 minus c over 4. And we are interested in sum of k values. So, and we can observe that the sum of the two c solutions, let's call them c1 and c2, is negative 80, because plus minus 25, they cancel each other. So k1 plus k2 values will be twice that constant, or negative 3.5 over 2 instead of 4, minus sum of c1, c2 values divided by 4. So we get negative 7 over 4 minus negative 80 over 4, so plus 20. And that gives us 73 over 4. So the sum of the numerator and denominator, and the answer is 77.